I'm going to go over free response question number 1 from the 2021 AP Calculus BC exam. Please keep in mind that this video was created before the College Board released any official scoring guidelines for these questions. So we have question number 1 here. The density of a bacteria population in a circular dish at a distance of r centimeters from the center of the dish is given by this increasing and differentiable function f, and we have some values here for r and f of r in our table. And the first part, we're going to be approximating f prime of 2.25. So we'll say f prime of 2.25. And we have to write down approximately equal to. If we put down equals, that would probably lose a point. So be sure to write approximately equals. And the best way to do this is just to calculate the slope between these 2 points. So we know it's going to be the change in these 2 values, so we're going to have 10 minus 6 over the change in these 2 values, 2.5 minus 2. And I don't think we need to put down units for this one because we are now going to use correct units to interpret the meaning of this answer in the context of the problem. And on the exam, of course, you would handwrite your sentences, but since it's kind of hard to write on the computer screen, I'm going to take the liberty of typing it. So I'm going to say f prime of 2.25, represents the rate at which the density of the bacteria is increasing with respect to the distance, r, and we have to use units here. So the density is milligrams per square centimeter. I'll just abbreviate this and say mg, milligrams per square centimeter, but then we have to do per centimeters because this is the rate of change of the density with respect to the distance. And I believe you might also lose a point if you don't put down at distance r equals 2.25 centimeters. I think they like you to, make some sense out of the 2.25. So this should be an okay answer for part A. I'm going to clear this, and we will move on to part B. Obviously, this answer right here does not need any simplification. You can just leave that exactly how it is. So here we have our part B. As soon as it comes up, you will see that we have to use a right-Riemann sum to calculate this integral right here. We have the total mass in milligrams of the bacteria in the dish is given by this expression right here. So we're going to approximate this. So I'm going to say this approximately equals to, I'm going to start with the 2 pi in the front. And then, now this is something that I got a little bit worried about on the exam, but it turned out to be okay. We have this extra factor of r right here. So we're not just going to use these values to do our Riemann sum. We have to make kind of another row down here. We're going to say r times f of r. That's what we're being asked to integrate. And we'll get some values for that. So we just have to multiply the values in each column. So we have 0 times 1 is 0, 1 times 2 is 2, 2 times 6 is 12, 2.5 times 10 is 25, 4 times 18 is 72. And so we're going to use a right Riemann sum with the 4 subintervals indicated by the data in this table. So we're going to have this times the difference in these, and then we're going to add, I'm going to use different colors here, this times the difference in these because we're doing a right Riemann sum. Then we have this times the difference in these, and I'll use purple, this times the difference in these. Alright, so let's go ahead and write this down. So our first part is going to be 4 minus 2.5 times 72. Then we have plus 2.5 minus 2 times 25 plus 2 minus 1 times 12 plus 1 minus 0 times 2. And you can, again, just leave your answer like this. No need to simplify anything. In fact, if you didn't want to have 72 right here, you could have still had the 4 times 18, and that would have been okay as well. So this is it for part B, and then we're going to move on to part C. And sometimes it takes a while for this to load, so here's part C. So for our part C, we're basically going to be explaining whether this answer was an underestimate or an overestimate. So we have to explain whether the approximation was an overestimate or underestimate of the total mass of the bacteria. And you don't really need to explain that much for this. It is an overestimate because if you recall, that function r times f of r was increasing. So whenever you have an increasing function, I'm just going to draw any increasing function right here. Well, let's do it. Okay. And if you use a right Riemann sum, so again, you're going to be, starting from here, going like this, going like this, going like this for however many intervals you need, you're going to have this extra area on the top here. So we're going to say that it was an overestimate. And I think all you really have to say here is that a right Riemann sum was used for an increasing function. And that should be it. I think Riemann has to be capitalized. Okay, so this should be it for part C. Now I'll clear this out and go on to part D. As soon as it comes up, any moment now. Here's part D. So in part D, they actually gave us a model. So now they gave us G of R, which is kind of a model for this between 1 and 4. Now, don't waste time doing this on the test, but if you plug in some values into this, like, see, if you plug in 1, don't do 0 because 0 isn't in this interval, so 0 wouldn't be a good value to plug in here. But if you plug in 1, for instance, 1.57 is right about pi over 2. So if you have the cosine of pi over 2, that's going to be 0. And so sure enough, 2 minus 0 would be this 2 right here. And then if you plug in 4, square root of 4 is 2. Cosine of pi over 2 times 2, well, that's the cosine of pi, which is a negative 1. You cube it, it stays negative, so you have 2 minus negative 16, which is 18. But don't waste time figuring all that out on the test. So we're looking for what value of k between 1 and 4 is g of k equal to the average value of g of r on this interval. Now the first thing I'm going to do is input this function into the calculator, so I have it in there. So I'm going to go into my y equals menu, and I'm going to just stick this function right into y1. So I'm going to say 2 minus 16, open parentheses, cosine of 1.57 square root of r. We're going to have to use x instead of r. And, oh, why didn't it give me an open parentheses? I thought I put an open parentheses before the cosine. Let's do that again. So I'm going to go back a little bit. Whoopsies. That's not where I wanted to go. So I'm going to go here and I'm going to insert an open parentheses. Okay, that's good. So that way at the end here, I can put down a close parentheses and then cube this. Alright, so now I've got the function in there. So now let's go back and read the rest of the problem. So we need the average value of g of r. Well, what's the average value of g of r on this interval? Well, it's going to be the integral from 1 to 4 of g of r dr over 4 minus 1. This is just how you find the average value of a function. So we need g of k to equal this. So we need a value of k, because remember, on this right here is just a number. So we need a value of k. So let's first get a value for this integral. So I'm going to go into the calculator. Let's go back to the home screen. And I'm going to go to, actually, before I put down integral sign, we have to divide by 3, right? We have that factor of 1 over 4 minus 1. So I'm going to put down 1/3 in the front. And then I'm going to go to integral. So we have math 9. Integral, we're going from 1 to 4. And since I already put in the function, I'm not going to put it in again. Oops, I'm just going to go into here, over to here, because I already have it in y1. So we'll say function y1. So y1 is the function that we want to integrate. And this will be respect to r, which in our case is x on the calculator. And we'll get a value for that. It might take a few seconds because my computer's slow. All right, so there's our value for it. And now we need to know for what value of k does g of k equal this value. So I'm going to store this value. So I'm going to say store, and I'll put this into a, so alpha a. All right, this value is now stored. I'm going to go back. I think the best way to do this is just put this value into y2, and then to figure out which value of k, we can say that x is now k, is just find the intersection point of these curves. So I'm going to put alpha a. And now all I need to know is basically where do these intersect. I just need the x value, and that will be my k value in question. So I'm going to go to second, calculate, and then intersect is number 5. And it may take, all right, so it's graphing, that's my g of k that it's graphing. And now it's going to graph the value. So it's just going to be a straight line. Oh, it's still graphing the model. And then in red is the value. Now notice they intersect twice, but we're interested between 1 and 4. All right, first curve, say enter. Second curve, enter. Guess, enter. Enter. All right, it's computing. All right, so here we go. Here's our intersection point at x equals 2.584. So we'll say k equals 2.584. And this is the end of question 1.